All right, for the next activity, we're using some Hot Wheels track and some Hot Wheels cars. Now I love this because it offers a lot of different varieties of experiments that your students can do, and that's what you want. You want to be able to demonstrate a basic concept and then give it over to the kids for them to develop their own experiments and or take a common experiment and then maybe change up the variables or develop their own variables in order to test, maybe change the way they're testing in terms of measurement. We want to measure distance instead of time. We want to measure height instead of distance, vertical or horizontal distance, for instance, whatever it happens to be. But when you have the opportunity, please give them the chance to make those choices on their own. They'll be more engaged, they'll do a better job. And even if it doesn't work, there are a lot of experiments that don't work, and they need to understand that. That's an essential part of the process. It's not that they do the experiment and then it all magically happens.
Can I just say that this is how you incorporate the science and engineering practices?
Right, exactly.
This is it.
Right.
You let the kids do the work, ask the questions, and come to conclusions.
Right. And the standard says let the kids, especially fifth grade, develop their own experimental processes. Mm-hmm. So if you're showing them everything, you're making the wrong step. One, you're doing too much work for yourself, and two, you're not letting them learn as much as they can from the experience. So in this case, we're using Hot Wheels cars to talk about basic forces of motion. We're using a ramp to introduce how the amount of force might affect the motion of an object. In this particular case, this is a good example of how you can tweak a basic activity to make it much more engaging and much more interesting. On the flip side, if you limit what they are doing, you can then kind of take the heart out of the activity and not even realize it up front. So in this case, we're using the Hot Wheels cars and the track. The way this track works is you've got pieces. There are some rails on the back end of the track, and there's a blue clip. The clip goes in the bottom of the track. So from the front side, it looks like this. The back side looks like this, and it just clips in. You'll hear a little click. And then the back side of your other track slides in. You hear a click. So this is the track. Now, what you want to do is the car is going to be on a slope, and they're going to let go of the car. And what you want, my finger's in the way on that one, let me get this back. You want the car to stop there, at the end, by itself. Kids aren't touching it, kids aren't stopping it, no one's foot's there, we're not putting a bunch of tape at the end of this necessarily. We want the car to stop by itself. So this is a lot of finesse going on. Now, if you do this normally, what happens is the kids will say, okay, we're going to start the car at this spot, we're going to let it go. Because they can't push it, right, that would be inconsistent results. They just have to let it go. And get it to, oh man, it went too far. So now they have a question. Thank you. Do I need to add more force or use less force? How do I get more force? Well, I need to move the car up the ramp. So they already know that answer. But now you're asking them a different question. You're saying, how much do you need to move it? So now they need to start estimating the ramp height with the distance the car is going to travel. Now you're not going to use these. You're going to use 10 pieces of this. So it's a much longer track. But we use just a simple clothespin, and the clothespin is used because it allows the kids to back the car up to it, and then have a consistent start point. And then you'll let it go, and then the car will start. Okay, so the car stopped far too short. They need to then adjust it. Now, your kids will have to have a discussion in the group. How far and what direction will you move it? The direction should be pretty obvious to them for the most part. But they need to say, shall we move this a little bit or a lot? What's the difference on that? How much farther do we need to go? They need to talk about it before they move it. Because what happens usually is someone in the group grabs the clip and then pulls it off, and then they have a discussion. And they're like, okay, great, we need to move it down just a little bit. And then they go back to it, and then they have no idea where on this they left off. So now they have to redo that part. So it can be a little frustrating for them. So tell them to leave it there until they decide they need to move it. And really, they should just be kind of opening it up. They don't even take it out, just open it up slightly and slide it. That's their best bet. Now, when you're done, you can measure the height of this with a tape measure. We'll show you that in a second. So you can get some definitive results off of it, and then you can start comparing car to car, because each car is going to be different. Okay. So this is the base one. So you can extend this lesson for multiple days, depending on how far you want the kids to go with it. So in our experimental process here, we're going to have some cars, and we're going to use like track here. Now I use 10 pieces of track. Whatever fits in your classroom is going to be the right size for you. Make that determination based on what you want. In this case, we've just taped the track up onto the top here, and to make our ramp, and we've produced a little bit of a ramp going down the side there. So we'll go back here. Stacey, you can have the clip there for me.
Yep.
And if we can slide back the camera. All right, so we're going to use the car, and we're going to roll it down this track. Now, what your kids are going to do is they tend to assume that we need a lot more force than they really do. So they're going to put that clothespin way back up at the top, which is far too much. So we put our car up here. Again, we back the car up. We do not push the car. We just let it go naturally. And it goes off the edge of the track and continues to keep on going, rolls across the rim. We have far too much force. We need to then have a discussion as a group. We need to go up and we go down. Stacey, what do you do?
Oh, I guess we have to go lower to move it down. Let's move it.
All right, so we'll move down significantly because it didn't even stop on the track. So we're going to start it again. We're still far too far. And this is, again, they'll move through gross processes and then finally get it down. So they'll keep moving until they kind of finesse it in there and then zero in on the spot. And we're still going too far for that car. We're going to slide it down a little bit. In any case, this is the way it should work. The kids should continue going. Go ahead and they should be working on the process as they keep going, getting dialing in closer and closer. So now the car is within a few inches of being done. We're going to slide it down a little further. Now, most kids, again, will be shocked when we need a little bit of force to get this job done. So again, a nice little bit of cognitive dissonance there for the kids to go through. Now, we're pretty close to this point. Here's something you need to know for the kids, is that you will get inconsistent results. There's some slop in the system. The kids need to be prepared for that, and you need to give them a little bit of warning so they don't think they're doing something wrong. So the car is going to stop here for sometimes, maybe it'll stop right up here, next time it'll roll down there, even if they change nothing in this process. So you're looking for them to say, okay, the car is going to stop at the edge as close as they can 3 times in a row before they come to get you to show you what they're doing, okay? So 3 times in a row. That might take them 5 or 6 times to get the 3 good rolls. That's okay. And so, like, if they get too short or they go a little farther, their immediate response, and this is understandable, is to change where they start. Tell them to resist that urge. Roll it multiple times without changing how much force you have on it if they're close. And then see if they can kind of get it that way. If they keep messing with the clothespin after every result, they'll keep chasing their tails essentially. So if 2 or 3 times or 4 times go on and they're really close to it, they know they don't need to move that clip much, if anything. So they need to work through that failure, that inconsistency to get it right. Now, once they've got it dialed in and they get it 3 or 4 times in a row, then they can come get you and you can kind of see what's going on and say, okay, this is good. Once they've got car number 1, okay, then you can introduce some different variables. So use a scale, for instance. Digital scales work best because there's not much weight for these cars. And measure the mass of each car. They can record that and then make estimates and their own predictions in terms of, is this car slightly heavier? Is this going to go further down the track? How hard do we need to adjust the clip, for instance? You can also take on weights to the car, like a washer or something to the top of the car. If you want to find out where is this, the easiest way to do it is you take measure and just have them measure from the clip straight to the floor. In this case, we're looking at 18 centimeters. So that's my goal for car 1 is 18 centimeters. Now car 2 might require 16 centimeters or 20 centimeters. It might go up or down based on the mass and based on the quality of the car. I mean, sometimes the wheels get wonky or whatever. But so this allows them to work repeatedly and very quickly with this in terms of using this ramp and getting the car to stay straight, for instance, stay within the track so that it's not rolling all over the room. The next thing you can do with the track, this is clearly not in one session, so the next day or come back to it after a few days, is you can cut pieces of material, whether it's foil, for instance, I guess some sandpaper here, or some construction paper, and lay them in to the track, put a little bit of tape on them on the back side, and then you can use this as a friction experiment to say which of these surfaces is going to either stop the car or let the car go. So for instance, one of the things we're trying to do is, again, how do the kids apply this? Don't just say which of these is smoother or has more friction. That's pretty straightforward. They can touch it and understand that. Say, okay, you're going to use any of these materials, and now I want you to stop. I want to leave this here. So this is the same distance, or a set distance. I need it to stop farther, maybe right here, for instance. So now I need to add some more friction to this system. So I'm going to use these pieces of paper, one type or another. Maybe the car doesn't go far enough, so I want something smooth like a foil or wax paper, or I need the sandpaper to kind of slow the car down. So that just enough. Maybe I don't need a full sheet, I need a half sheet. Whatever it is, you want the kids working through this process so they're actually actively engaged in this material and thinking through the problem ahead of them. So that's what we do with Hot Wheels cars. If you get more track or you want to extend it, one of the things you can do is have the kids you can have it start up here, you can even have it start up higher on the wall, for instance, and you can put things underneath the track and make a gentle hill, for instance, and then your goal will be, can you get the car to go all the way to the end just using gravity? Now, we've had tracks go all the way from one end of the custom to the other, and have it be off of one bit of gravity. Usually it's kind of stacked up on the wall, pretty tall, and it's hard for them to do it, but it's a great job, especially after you've done this activity in the class, and you have in your recess or some other time that's a little bit flexible. You can kind of get back to this and think about this process in a little more open-ended way, and you want to do that without teaching them this. It reviews the information and gets them to apply it in a different way. Thanks.